Hello, Vanakkam. I am Sujit. Welcome to Physics 2020. So today in this section we are going to solve some more numericals of relative velocity in two dimension. So in the previous section we have discussed the theory and two numericals of that is relative velocity in two dimension. So in this section we are going to solve three more numericals of the same section, that is relative velocity in two dimension. So the third problem. So what is the question? Rain is falling. So making an angle with a speed of 50 km per hour. 50 km per hour. So making an angle 37 degree. Okay, making an angle 37 degree. So a boy is riding the bicycle here. A boy is riding the bicycle here, okay. So with a speed of 40 km per hour. 40 km per hour. So understand the situation. Rain is falling with a speed of 50 km per hour, making an angle 37 degree. A boy is riding the bicycle with a speed of 40 km per hour. So what is, we have to find what is the velocity of the rain as seen by the man. As seen by the man. First question. Second question. In what direction he should hold the umbrella to keep away or to escape from the rain? That is the second question. Okay. So here rain is falling in a certain degree, okay, certain angle. So we have to make use of that is component vector form, okay, component vector form. So here so rain is falling in this direction, okay, making an angle 37 degree, okay, 37 degree with a speed that is 50 km per hour, okay, 50 km per hour. So this angle is 37 degree. So this vector can be resolved into two components. So horizontal component and vertical component, okay. So this component is 50 cos 37. This component is 50 sin 37. So the side which is closer to the angle, you can take that is the cos component, okay, cos component. Another component is the sin component, okay. So 50 cos 37 and 50 sin 37. So the angle 37 degree is the famous triangle. Okay, so that is 3. So the sides are 3, 4, 5. Okay, 3, 4, 5. So 50 cos 37. 50 into cos 37 adjacent side by hypotenuse, that is 4 by 5. 4 by 5. So 10 times. So 10 into 4, that's equal to 40. 50 sin 37. So 50 into sin 37 opposite side by hypotenuse, that is 3 by 5. So 10, that's equal to 30. Okay, 30. So this is velocity of the rain with respect to the ground. So that is that velocity 50 can be resolved into two components. So this is along the positive x-axis and this along the negative y-axis. Okay, the velocity of the rain can be splitted or can be divided into two components. One component along the positive x-axis, another component in the negative y-axis. So we can write that is velocity of the rain with respect to the ground is equal to 40 in the positive x-axis, that is 40 I cap. So this is in the negative y-axis. What is a unit vector? That is j vector. So minus 30 j cap. So this is the velocity of the rain as seen by the ground. Okay. So the next is velocity of the man. So it is horizontal, it is moving in the positive x-axis. So we can write that is velocity of the man with respect to the ground is equal to, that is 40 I cap. Okay, 40 I cap. So what we have to find? Velocity of the rain as seen by the man. Velocity of the rain as seen by the man we have to find. So what is the formula? That is, we have studied the formula. That is velocity of the rain Vrm. So velocity of the rain with respect to the ground minus velocity of the man with respect to the ground. You understand? That is VAB is equal to velocity of A with respect to ground minus VB with respect to the ground. So we have to find that is velocity of the rain as seen by the man. So velocity of the rain with respect to the man is equal to formula velocity of the rain with respect to the ground minus velocity of the man with respect to the ground. Okay? So that's equal to velocity of the rain with respect to the ground. We have found this component. Okay, so 40 I cap minus 30 j cap. So minus what is velocity of the man with respect to the ground? That is 40 I cap. Okay, 40 I cap. So this 40 I cap minus 40 I cap get cancelled. So velocity of the rain with respect to the man is equal to minus 30 j cap. 30 j cap. So what is the feeling? That is, the man moving in the cycle feels that the rain is coming vertically downwards, because 30 minus 30 j cap, it is in the negative y direction, falling vertically downwards. Actually that is the man in the ground. So what is the feeling? That is very, very important. The man in the ground feels that the rain is falling in a certain angle, 37 degree. But the man moving in the cycle with a speed of 40 km feels that the rain is coming vertically downwards. Okay, minus 30 j cap. Okay, j cap. So here plot, this is x-axis and y-axis. So 30 j cap means, here you have to, that is 30. Okay, j cap is the unit vector in the negative y direction. So here. So what is velocity of the rain as seen by the man? Is the right answer is, that is velocity of the rain with respect to the man is equal to, that is 30 j cap. 30 j cap. So velocity means we have to say the direction. So 30 is the magnitude and minus j is the direction. So it is falling vertically downwards. Okay, vertically down. So what is the speed of the rain? So Vrm is equal to 30 km per hour. That is the answer. Okay, velocity of the rain has been, speed of the rain as seen by the man. So 30 km. Only magnitude we have to take. So velocity means we have to say the direction. So that is 30 is the speed, direction vertically downwards. Okay, vertically downwards. So man is riding the bicycle here. So the rain is coming For the moving man, the rain is falling vertically downwards. So, second question, in which direction he should hold the umbrella? So, he feels that rain is coming in this direction. So, definitely, he should hold the umbrella like this. Okay? He should hold the umbrella vertically downwards. So, the man in the cycle, so he feels that the man in the cycle feels that the rain is falling like this. Rain is falling like this. Am I right? Falling vertically downwards. Vertically downwards. So, in which direction he should hold the umbrella? So, he should hold the umbrella in this direction. That is the answer for the second question. So, the man in the cycle should hold the umbrella perpendicular to the downwards. Correct? Clear? So, fourth problem. So, rain is falling in this direction. So, making an angle of that is 53 degree. Okay, 53 degree. With a speed of 50 km per hour. 50 km per hour. So, man is moving in a cycle in an inclined plane. So, this angle is 37 degree. A man is moving, riding the bicycle in an inclined plane. Okay, inclined plane with a degree of that is 30 with an angle of 37 degree. Okay, with a speed of that is 100 km per hour. Okay, 100 km per hour. So this is the situation. So rain is falling in an angle of that is at an angle of falling downwards with a speed of 50 km per hour in an angle that is 53 degree. So man is moving in an inclined plane. Okay, inclined plane of angle of inclination that is 37 degree with a speed of 100 km per hour. Okay, 100 km. So here also we have to find velocity of the rain. Velocity of the rain as seen by the man. Velocity of the rain as seen by the man. First question. Second question. In which direction he should hold the umbrella, hold the umbrella to escape from the rain. So here, understand the situation, that is both the rain and the man is moving in a particular angle. Okay, particular angle. So we have to make use of, that is component vector form. Okay, component vector form. First, rain. So rain is falling with a speed of, that is 50 km per hour at an angle of 53 degree. So this angle is 53 degree. Okay. So the velocity of the rain can be divided into two components. So 50, this component is, that is 53 cos, sorry. So this velocity is 50. Okay, 50. So 50 cos 53. So this component is 50 sin 53. Okay. So 53 triangle. That is also famous triangle. So this angle is 53. Okay, 53. 4, 3, 5. So another famous triangle is, this is also famous triangle, that is 37 degree. 37 degree. 37 degree. This is 3, 4, 5. Okay, so 50 cos 53. So 50 into cos 53. So adjacent side by hypotenuse, that is 3 by 5. So 50 sin 53. So 50 into sin opposite side by hypotenuse, that is 4 by 5. Okay. So 10 times. So that's equal to 30. So 10 times. So that's equal to 40. Okay, 40. So the velocity of the rain. So velocity of the rain with respect to the ground. Okay, so velocity of the rain with respect to the ground 50 degree, 50 km per hour. But it is falling in a certain angle. Okay, certain angle, that is 53 degree. So that's why the velocity of the rain with respect to the ground can be divided into two components. One component along this direction and one component along this direction. So this is negative x-axis. This is negative y-axis. So we can write, that is velocity of the rain. Come on. Velocity of the rain with respect to the ground is equal to negative x-axis. So minus 30 I cap minus 40 j cap. Clear? Velocity of the rain with respect to the ground. So one component in the negative x-axis, negative x-axis. So when we divide, so this is the negative x-axis and another component, one component along this direction and another component along this direction. Positive x-axis, negative x-axis, positive y-axis, positive, negative y-axis. Clear? So another. So the man is moving. So here the man is also moving in a certain angle. Okay, certain angle. Because the man is moving in a inclined plane. Okay, inclined plane of inclination 30 degree, 37 degree. So the velocity is acting in this direction. Okay, in this direction. So one component. So making an angle of 37 degree. 37 degree. So what is the velocity? That is 100. Okay. So one component along this direction and another component along this direction. So this is 100 cos 37 and this is 100 sin 37. Okay. So 37, this is the triangle, 37. So 100 right, 100 into cos 37 adjacent side by hypotenuse, that is 4 by 5, 100 sin 37, that is opposite side by hypotenuse, that is 3 by 5. Okay? So 20 times 20 into 3, that is 60. So 100 times 20 times, okay, 20 times 20 into 4, that is 8. So we can write velocity of the man with respect to the ground. Okay, ground. So this is positive y-axis, this is positive x-axis. So we can write 80 I cap plus 60 j cap, 60 j cap. This is the velocity of the man with respect to the ground. Clear? So both the rain and the man is moving in a certain angle. Okay, certain angle. So we have to make use of that is component vector form. Okay, component vector form. Clear? So we have found that is the velocity of the rain with respect to the ground in component vector and velocity of the man with respect to ground in the component vector. So what we have to find? So our question is, so read down the first question. Velocity of the rain as seen by the man. Velocity of the rain. Notation, velocity of the rain. So we are velocity of the rain as seen by the man. So what is the formula we have studied? That is V R G minus V M G. Okay. Velocity of AB is equal to velocity of A with respect to ground minus velocity of B with respect to ground. Same formula we are using. Velocity of rain as seen by man is equal to velocity of rain with respect to ground minus velocity of man with respect to ground. So that's equal to velocity of rain with respect to ground minus 30 I cap minus 40 j cap minus velocity of man with respect to ground. So minus 80 I cap plus into minus 60 j cap. Okay, j cap. So minus 30 minus 80. So that's equal to minus 110 I cap minus minus 40j minus 60j minus 100j minus 100j. This is the velocity of the rain with respect to the man. So that is the answer for the first question. Velocity of the rain as seen by the man. Velocity of the rain as seen by the man. Clear? So what is the speed of the rain as seen by the man? So this is vector form only. Okay, vector. So if you want to find the magnitude, what is speed of the rain as seen by the man? Speed of the rain. Speed is equal to modulus of V Rm. Vector. So that's equal to square root of yes, so square root of that is 110 square plus 100 square. Okay, 100 square. So if you solve this, if you find this value, we can get the speed. Okay, you can get the speed. Clear? So second question, in which direction he should hold the umbrella? In which direction he should hold the umbrella? So plot the value, that is yes, V yes, velocity of rain with respect to man is equal to minus 110 I cap minus 100 j cap minus 110 I cap, that is negative y axis. In the negative y axis, that is 110 minus 100 j cap in the negative so negative x axis, so negative y axis, this 100 j cap, so 100. So 110 in this direction and 100 in this direction. So what is the resultant? So resultant must be in this direction. Okay. So the velocity of the rain as seen by the man has two components. One component along the negative x-axis, one component along the negative y-axis. So what is the resultant of these two? So the resultant must be acting. So according to parallelogram law of vectors. Okay, parallelogram law of vectors. So both vectors, they are acting in the 90 direction. Okay, 90 degree. Okay, 90 degree. So parallelogram law of vectors. Kadam. Parallelogram law of vectors. So the resultant is acting in this direction. Resultant is acting in this direction. So the man feels that the rain is coming in this direction. The rain is coming in this direction. So which makes an angle theta. So which makes an angle theta. Okay, theta with the horizontal. So definitely he should hold the umbrella in this direction. In this direction. In this direction. Okay. So making an angle theta. Clear? In this direction. So what is the exact angle of, that is how, in which angle he should hold the umbrella from the vertical. Okay, vertical. So from this, that is tan theta is equal to opposite side. Okay, opposite side, that is 110 divided by adjacent side, that is 100. 110 divided by 100. So 0, 0 get cancelled. So tan theta is equal to 11 divided by 10. Okay, theta is equal to tan inverse of 11 by 10. Okay, so this must be the angle. Okay, this is the angle of inclination of the umbrella which he should hold from the vertical. So if the rain is coming down, okay, vertically downwards means he has to hold the umbrella like this. Okay, hold the umbrella like this. If the rain is coming in this direction means he has to tilt the umbrella. Okay, tilt the umbrella. How much angle? So tan inverse of 11 by 10. Okay, tan inverse of 11 by 10. That is the answer. Okay. So problem number 5. A man standing on a road has to hold his umbrella at 30 degree with the vertical to keep the rain away. He throws the umbrella and starts running at 10 km per hour. He finds that raindrops are hitting his head vertically. Find the speed of the raindrops with respect to the road and the moving man. So here we have to find that is velocity of the rain with respect to the road. Okay. Velocity of the rain with respect to the ground. With respect to the road means velocity of the rain with respect to the ground. Okay, with respect to the ground. So velocity of the rain with respect to the, so what is the formula? Velocity of the rain with respect to the moving man is equal to velocity of the rain with respect to ground minus velocity of man with respect to ground. So from this formula, velocity of the rain with respect to ground is equal to velocity of the rain with respect to man plus velocity of the man with respect to ground. So here, so this is the formula. Okay. So a man stands on a road, has to hold his umbrella at 30 degree with the vertical to keep the rain away. So for a man at the road, he feels that the rain is coming at an angle of 30 degree. Okay, 30 degree. So with the vertical to keep the rain away. He throws the umbrella and starts running at 10 km per hour. So the man is running in the horizontal direction. So at that time he feels that the rains are hitting his head vertically downwards. Okay. So from the question what we can, that is we can draw a vector diagram. We can draw a vector diagram. So man is running in this direction, okay, in this direction, and with that is velocity of the man with respect to ground. So the magnitude also we know, that is 10 kilometer. Okay. So for the moving man, he finds that is the vertically, the rains are falling vertically. So velocity of the rain in this direction, velocity of the rain with respect to the moving man. So from this what we can understand, velocity of the rain with respect to man plus velocity of the man with respect to ground is equal to velocity of the rain with respect to the ground. So the resultant must be like this. So the addition of these two components, Vrm plus Vmg is equal to Vrg. So definitely, so the resultant of these two vectors is, yes, Vrg. Okay, Vrg. That is Vrg. So which makes an angle that is 30 degree with the vertical. Okay, 30 degree. Clear? So from the question we draw the vertical, that is vector diagram. Okay, vector diagram. Okay, so from this diagram, that is, if you consider this is the right angle, okay, this is a right angle, 90 degree. So from this sin 30 is equal to sin 30 is equal to opposite side. Opposite side means this side. So this is nothing but that is 10 divided by hypotenuse, that is Vrg. Okay, so that's equal to, that implies Vrg is equal to, Vrg only we have to find, that is the velocity of the speed of the rain with respect to the road. Vrg is equal to 10 divided by sin 30. So that's equal to 10 divided by, what is sin 30? That is 1 by 2. Okay, 1 by 2. So that implies, so 10 into 2. So that's equal to 20, yes, kilometer per hour. So that is the answer. So that is the answer for the first question. Vrg, that is velocity of the rain with respect to the road. Okay, velocity of the rain with respect to the ground. That is ground is equal to, that is 20 kilometer per hour. 20 kilometer per hour. That is the answer. Now we know that is Vrg. Okay, so Vrg, so which makes an angle 30 degree. Okay, 30 degree. So we can write that is Vrg is equal to, it is acting in this direction, that velocity can be divided into two components. Okay, two components. So Vrg is equal to that is 20. So this is 20 sin 30. So this is 20 means this vector is 20. Okay, that is 20 cos 30. And this component is, that is 20 sin 30. Okay, 20 sin 30. So we can write 20 cos 30, how much? That is 20 into cos 30, that is root 3 divided by 2. So 10 root 3. So this 20 sin 30, that is 20 into 1 by 2. So that is 10. Okay. So we can write that is Vrg is equal to 10 I cap minus that is 20 10 root 3. Okay, 10 root 3 j cap. Okay, 10 root 3 j cap. Now we have to find, that is velocity of the rain with respect to the moving man. So velocity of the rain with respect to the man. Okay, with respect to the man. So that's equal to velocity of the rain with respect to ground minus velocity of the man with respect to the ground. So that's equal to velocity of the rain, that is 10 I cap minus 10 root 3 j cap. Okay, minus velocity of the man with respect to the ground, that is 10. Okay, 10 in this direction, that is 10 I cap. Okay, 10 I cap. So 10 I cap minus 10 I cap cancel. So that's equal to minus 10 root 3 j cap. So this is the velocity of the rain with respect to the man. Okay, velocity of the rain with respect to the man. Clear? So we have to find, that is find the speed. Speed means this is the velocity. Velocity means magnitude with direction. So speed means, so V Rm is equal to without direction, that is 10 root 3. That is the answer. Okay, 10 root 3 is the answer. Clear?